if I take a look at 34, 34 says we have 30, 14, 8, and 2. Is this the one you're talking about? Yeah? Okay. What can I do? Well, I'm either dividing by some number or I'm, what? Oh, thank you. Yep, that should be 20. Thank you for correcting me. That should be a 20. Thank you. So, you guys, how many of you guys notice that I'm decreasing? So if I'm decreasing, what are my two possible operations that I'm doing if I'm decreasing? Nick? Excellent. So I'm either doing subtraction or I'm doing division. All right? That's something to remember. So anticipate what options that you have. All right. There's nothing I can divide 20 by to get 14. All right. Nothing easy. So I'm going to try subtraction. So 20 minus 14 is 6. So I'm going to subtract 6 off. So 20 minus 14 is 6. All right, well 14 minus 8 is also 6. Or 14 minus 6 gives me my 8. 8 minus 6 gives me my 2. So now I have my pattern. And the directions were find the next two terms. All right, well 2 minus 6 is a negative 4. Negative 4 minus 6, or plus a negative 6 is negative 10. Are you cool with that? Okay. What else can I do for you guys? Yeah. I'm sorry? 42. So the moment you get some fractions in there is the moment things start to kind of get a little bit kooky. Like you got to kind of figure out what you're doing. All right, so if I look at 42, I have 12.
Teachers and students, please pardon the interruption. For recess for today, grades 3 through 8 will be going outside per normal. Please wear your snow pants and snow boots to go on the field outside. You must have full attire. Grades 1st and 2nd will be utilizing the gym for the recess for today. Kindergarten will be staying in their classroom for today. Once again, grades 3 through 8 will have normal outdoor recess today. 1st and 2nd grade will utilize the gym. Kindergarten will be having indoor recess for today. Thank you.
Okay. How many of you guys noticed that we're going down? Okay. How many of you guys notice it's alternating between negatives and positives? Okay. If it's alternating between negatives and positives, Chris, does that mean we're subtracting? Does that mean we're adding? Is it possible to alternate between negatives and positives and add and subtract? Add or subtract? What do you guys think? It's not possible. I can't start with a positive number, then get a negative number, and then get a positive number, and then get a negative number by adding a number, or by subtracting a number. Now we could add 2 and then subtract 1, and then add 2 and subtract 1. That is possible. Okay, that's the first thing. So I'm going to not look at that option. I'm going to look at the option of multiplying or dividing. All right, so the first thing I want to do is get rid of those 2 right there. Somebody tell me, what can I do using multiplication or the division to get from 12 to negative 4? You all have a marking pen in your hand. You're all looking at number 42. What can I do to 12 to get negative 4? Victoria? I could divide by negative 3. Divide by negative 3. What's the same thing as dividing by a negative 3? Because I need you guys to think of this for the next one. What's the same thing as dividing by a negative 3? Colin? Yep, that's the same thing as multiplying by a negative with 1/3. How many of you guys are cool with just that part? Okay. What what can I do to a negative 4? Well, can I, since this is a fraction, I'm going from an integer to a fraction. All right, clearly I'm either dividing or I'm multiplying. All right, if I divide negative 1/4 by a negative 3, do I get a positive 4/3? Guys, I need you listening. I need you all being able to answer yes or no. If I divide negative 4 by negative 3, do I get a positive 4/3? How many guys say yes? How many of you guys say no? All right, yeah, I do. I'm going to divide by a negative 3. Now I'm going to check the last one. Now, I don't like thinking about dividing a fraction by a fraction, which is why Colin was so smart to recognize that dividing by a negative 3 is the same thing as multiplying by a negative 1/3. So if I multiply 4/3 by a negative 1/3, do I get a negative 4/9? If I multiply 4/3 times a negative 1/3, do I get a negative 4/9? Jacob? Yeah. So my pattern is multiply by a negative 1/3 or divide by 1/3. So what that means is my next two terms in my sequence are going to be negative 4/9 times a negative 1/3, which is going to give me a positive 4/27, and then I'm going to multiply that by a negative 1/3 as well. All right, so seeing the fractions, it doesn't matter. If you noticed, I blocked off all the numbers but the first two, and I figured out what we could possibly do here. And then we move on to the next ones, and I'm like, can I possibly do the same thing? I will give you, sit up please, I will give you ones with fractions on a test or a quiz. All right, because I need you guys being able to deal with fractions. What else can I do for you guys? Nick? Number 2. All right, number 2 said I have 4, 6, 9. That 13 halves kind of throws me off, doesn't it? So, what can if I add 2 to 4, I get 6. If I add 3 to 6, I get 9. The problem is it's not working on the other one. How many of you guys agree with that? Okay. So now we need to think about multiplication. All right. This is what I want you guys to think. Chris, sit up. This is what I want you guys thinking about. I'm going to look at just these two. 4 times some number gives me 6. How can I figure out what that number is? If you guys didn't know what to do on 2, you're writing this down. 4 times some number gives me 6. How can I figure out what that number is? Peter? How can I figure out what that number is? Yeah, I can divide both sides by 4. So let's call that x. X is going to be 6 divided by 4. Well, 6 divided by 4 is 1.5. So here, to go from 6 to 4, I'm multiplying by 1.5. Let's see if that works for the rest of them. 6 times 1.5 gives me my 9. 9 times 1.5 gives me my 13.5. So that is one way that you can figure out what am I multiplying that first one by to get my second. Well, just divide the second by the first. All right, the moment you see there's fraction going on is when you need to be like, okay, I'm multiplying by a fraction. I have to be, or I'm adding a fraction, or I'm subtracting a fraction. Okay, put this away, get your notes out. Come on. have the same people regularly sitting up at my high tops. So, in the end, who in here really wants to sit at those high tops? I mean, who actually is going to be sitting at them? Okay, so then I need you guys sitting at them. It's your week, if it's your day. Otherwise, if you don't, I'm just going to assign the people that are going to all the time just to sit at them all the time. So somebody is supposed to be up there today. I mean, I don't care if anybody sits at them, really. All right, but I know that I have Victoria and Isabella that like to sit up there all the time. I'll leave them up there if that's who wants to sit up there, and redo my seating chart accordingly. Okay, so today is the 20th. All right, we are still in 5.6, so 5.6 continue. Remember, your test is on Wednesday of next week. All right, today what we're going to be talking about is something called the arithmetic sequence. If you noticed in our homework, they were referring to these lists of numbers as sequences. All right, so when we have a list of numbers that has a pattern is called a sequence. A list of numbers that has a pattern is called a sequence. Come on, Jack, let's get moving, buddy. So let's take a look at these two sequences. If I wrote, what I want you to do is I want you to find the pattern. That's all I'm looking for you to do on these two sequences. So I'm going to split my page because I want to compare these. So here is my first one. -7, -3, 1, and 5. So I want you to do the pattern work that we did last night, and I just want you to find the pattern that's happening on this table. That's it. So what is the work I'm doing? What am I doing to my -7 to get my -3? Victoria? Add 4. Can I do the same thing to -3 to get 1? Excellent. So I'm just going to show adding 4. How many of you guys agree with that? Okay. Now the second one, I want you guys to do this. 2, -4, 8, -16. Now you notice that it's alternating between positives and negatives. So chances are we're not adding or subtracting if we're doing just one thing. And that's what I always want you thinking of, is doing one thing first. When you're done, check with someone sitting by you. So what am I doing to 2 to get -4? Nick? Excellent. If I multiply -4 by -2, do I get +8? Nick? Yep. And that works for all three of those, correct? Excellent. All right. So I want you to compare what's happening. In that first one, we are adding the same number. In the second one, we are multiplying by the same number. How many of you guys see that basic difference between them? All right, this first one is called an arithmetic sequence. This one is called an arithmetic sequence. You're all taking notes on this, please. An arithmetic sequence is when we are adding the same number. Now that number can be negative, but we are adding the same number. All right, when we are multiplying by the same number, this is called a geometric sequence. That's called a geometric sequence. We are focusing on arithmetic sequence today. In the future, you will talk about the geometric sequence. We are focusing on the arithmetic sequence. All right, so I need to come up with some vocabulary with you guys for us to understand what I'm doing, okay? So let's talk about some vocabulary. So let's talk about arithmetic sequence. Okay, first of all, we already talked about what the word sequence meant, so we don't have to repeat that. We're going to talk about a term. Term is each number in a sequence or list of numbers. So a term is each number in the sequence or each number in the list of numbers. All right, when we talk about a term number, that's like first term or second term. That's the number term in the list. So if I look at a list that's like 2, 4, 6, 8, 2 is my first term. 4 is my second term. Can you guys see what term number is? It's the what place it is. It's the first one or the second one or the third one. You guys with me so far? All right. Okay. We have something called a common difference. And the odd thing about calling it a common difference is it's the number that we are adding to each term to get the next term. This is the number we add to each term to get the next term. So your common difference, we're going to be using the variable lowercase d, because I'm going to give you a formula. We're going to be using a lowercase d. All right, so we want to know, so a common difference is the number that we are adding, not subtracting. So if it's subtraction, it's adding a negative. All right, so this is my terminology. Okay. So what I want to do is, there's a formula, and I want you to understand the formula and how we come up with this formula. All right? So I'm going to use the arithmetic sequence that we had there at the top to help us come up with this formula, and then we're going to use the formula. All right, so let's take a look at this sequence. So let's use our example. I have -7, -3, 1, and 5. All right. So we already determined that we were adding 4 each time. All right, so what I want to do is I want to write a formula for this sequence. So we can find any term in the sequence. So I could say, what's the 100th term in the sequence? And what you don't want to have to do is go add 4, add 4, add 4, add 4, add 4 100 times. That's going to be really laborious. So let's figure out a formula. All right, so let's figure out what we're going to do. You don't have to do this every single time. I want you to know where the formula comes from, so we're going to use this example to come up with the formula, okay? So I'm going to say n is my term number. All right, I'm going to say a of n is the value of each term. So I'm defining the variables that I'm using. Okay, so if I have a of 1, that just means my first term value. What is the value of my first term in my list? What was the value of my first term in my list? Serena? -7. So value of my first term was -7. What did I do to -7 to get my next term? So for my second term, what did I do to -7 to get my next term? Chris? I added 4. All right, and that gave me my -3. I'm just looking for my pattern. So here what I'm doing is I'm looking for a pattern so I can write my formula. So I'm looking for a pattern so I can write my formula. Again, you're not doing this every single time, but I want you to understand where it comes from. All right, so my third term, what did I do to -7 to get my third term? What did I do to -7 to get my third term? Colin? How many times? So I added 4, and then I added another 4. This gives me a +1. All right. How could I rewrite -7 plus 4 twice? How could I rewrite that? Peter? No. How can I rewrite adding 4 twice? Isabella? Not 4 squared. Jacob, help her out. Exactly, plus 2 times 4. All right, so if I take a look at my fourth term, -7 plus, well, how many times am I adding 4 to -7 for my fourth term? How many times am I adding 4 to my first term to get my fourth term? Jacob? 3 times. How many of you guys can see that? All right, because it would be -7 plus 4 plus 4 plus 4, which is 3 times 4. What do you notice? If I do my fifth term, it would be -7 plus 4 times 4. What do you notice about each of these values that I'm multiplying my 4 by? Remember that 4 is my common difference. That 4 that I'm adding each time is my common difference. What do you notice about what I am multiplying my common difference by each time in relation to my term number? So here in my third term, I'm multiplying my common difference by 2. In my fourth term, I'm multiplying my common difference by 3. In my fifth term, I'm multiplying my common difference by 4. In my sixth term, I'm going to be multiplying that common difference by 5. What do you notice is the pattern that you see between what I'm multiplying my common difference by each time. Talk to someone sitting by you, figure it out. What is the pattern that you see of what you're multiplying your common difference by with each term? What do you notice? On my sixth term, I multiply common difference by 5. On my fifth term, I'm multiplying my common difference by 4. So what's my pattern? Serena? So the number before what? The term number, right? So if my term number is 6, I'm multiplying by that common difference by 5. If I'm finding my 9th term, I have 7 plus. What am I multiplying my common difference by if I'm doing my 9th term? So Serena said I'm multiplying by the number before my term number. So what number am I multiplying my common difference by if I'm finding my 9th term? Ashton? 8. So this term, this number we're multiplying by is our term number minus 1. So in this one, it's my 9 minus 1. So let's come up with a formula. So let's say it's any term. So let's use n for our term number. Well, I'm going to start with that negative 7, and I'm going to add to it, well, n minus 1 times 4. There is my sequence for this. It's my first term. So here is my first term. And then here is my term number minus 1 times my common difference. So there is the formula for this sequence. So all of you find what the 100th term would be. So I'm going to use that sequence. I'm just going to flip and rewrite it. So a of n is equal to negative 7 plus n minus 1 times my common difference of 4. And I want to find the 100th term. All right, so what I'm going to do is I want to find my 100th term. So I want a of 100. So what do I have to do to find this 100th term? What do I have to do to find this 100th term? Peter? Well, how did you get 99? So 100 minus 1? Yep. Times 4, right? So all of you do that math. So I have negative 7 plus 396. Is that what you guys got? What did you guys get for your 100th term then? Colin, what'd you get? 389. So let's write our arithmetic formula, or arithmetic formula. Arithmetic sequence. So a of n is equal to a little a. That little a is your first term. Plus n minus 1, remember n is your term number, times d, where d is your common difference. So here is the formula. So tonight you're going to be using those formulas. You might be finding the formula and then using the formula, or you might just be using it. You guys cool? You guys good? Okay, you guys are good to go.